Okay, guys. So now we can move on to our second session. So we will directly start. Rumesh, let me hand it over to you.
Hi guys, can you hear me now?
Yes, we can.
Right. Okay. Sorry, I was on mute. Can you all see my screen?
Yes, we can.
Right. Okay. Uh, so today, what I'm going to discuss about is how to get the most out of your serverless application. So today I'll be talking about first I will start with the building blocks. I'll give a small intro about how we can start with what are the services that we can use, things like that, and I will discuss about the general design principles that we can use to get the best out of the service application. And then I will dive a little bit onto the service lens. I will explain what it is and how on each different architectural aspects can we get the best out of it. And finally, I will do a small example demo on the AWS well architected tool, which we can use to evaluate our architecture. So guys, when it comes to serverless, serverless was a hype since 2016. Now a number of people are using serverless, and it's nothing new. But I will go through the different layers and what are the building blocks that we can use. The first layer that I will be talking about is the compute layer. So in compute, primarily we have AWS Lambda. Even though I have added a API gateway and step functions here, API gateway is not directly related to the compute layer. But when it comes to Lambda, and most of the startups that we are seeing today are using Lambda with API gateway to build REST endpoints. And there are a lot of ways we can leverage AWS step functions as a state machine. So we can combine a number of Lambda functions in different states in our application. So that's about the compute layer. And then if we go to the next slide, in any application, we have a data layer. So in AWS, there are multiple building blocks that we can use to build applications on data layer. One of the popular NoSQL database is the DynamoDB, which AWS provide, and then we have S3 to store our application. And with these, also we have Elasticsearch, Amazon Elasticsearch, which is their own implementation of Elasticsearch, the managed service. So we don't have to worry about the infrastructure. They do all the management. What we have to do is we have to use the service. And if we are to get some subscription and real-time updates on this data, like for example DynamoDB, we can use AWS AppSync. And in another layer would be the messaging and streaming layer. In this aspect, AWS provide a simple notification system, and if we want to get data to AWS, we can use Kinesis Firehose, and to ingest data, we can use Kinesis. Uh, Another popular part of our applications, whether it be a web application or any other application, is the user management and identity layer. So here, AWS gives us a pretty good solution construct called Cognito, and in a deep level, we can use leverage their federated identities to build cool applications. And in AWS infrastructure, we have this edge concept where if we think about the global scale, imagine we have application which we serve data, the application serves on different regions, for example, US, India, Singapore. Uh, Rather than having a single location to serve these applications, we can use these edge locations. Even inside that region, there can be multiple edge locations, and we can make use of that to serve our application pretty fast. So to use build on top of the edge layer, we can leverage the CloudFront infrastructure. And another layer would be the system monitoring and deployment. So when it comes to any application, the monitoring part and deployment comes in. We have really high standard there. So when it comes to monitoring, one of the popular solution constructor in AWS is Amazon CloudWatch, and we can use AWS X-Ray to track the request where it goes and what are the resources that is being using. And for the deployment, when it especially comes to serverless application, we can make use of serverless application model, which is not recently, but about 2-3 years back, they introduced serverless application model. Underneath, we can make use of the code build, code pipeline to do the deployments. So that's about the building blocks of serverless. I know most of you might be aware of all these things. So let us discuss about the general design principles around what can we do generally to get the best out of these constructs. So there are different layers, as I mentioned. First one is the computing infrastructure. So when it comes to the compute infrastructure, like Lambda, what AWS advises to keep your functions really small and keep it very focused on single task. So that makes your function speed simple and singular. So if something goes wrong, it's really easy to either replace or debug or do anything. It's going to be really easy if you keep it singular and simple. And in Lambda model, we think about the concurrent request instead of the total request. So we have to think about the concurrency and how many requests that we are going to serve, things like that. And again, in the Lambda model, it's advised to share nothing, have the stateless manner. So you don't know, one time this request could come to one Lambda instance, and the next time another similar request could go to another different Lambda instance. So in AWS, they advise it's better to not to share anything. And another thing is we have to build our applications in a manner that it's hardware agnostic. So we don't have we shouldn't assume what are the hardware that we are going to get to our Lambda function. So try to build a solution that is hardware agnostic. And initially, when Lambda came into play, we could the ability when we design a Lambda function, we try to keep it very simple and very focused. So to get something done, we might there's a high probability that we need to make use of multiple Lambda functions. So earlier, what we people did was use the same Lambda to invoke other Lambdas. But now now we have introduced AWS has introduced the step function, which we can use as orchestrator, and which allows us to get many benefits, which will come in the later in the section. And in Lambda, we try to build everything in an event-driven manner, and always we have to think about the failures and duplicates. So, we have if something could go wrong, that will go wrong for sure. So we have to make sure that how we handle failure. So these are generic design principles that AWS advise for us to keep our eye on. So now it comes to the serverless lens. So before talking about serverless lens, in AWS, there's a architectural guideline called Well Architect Framework. There, people talk about reliability, performance, cost optimization, security, and operational excellence. So any service that we build being categorized into these pillars, and we can think of how to build a very good application which has better reliability. And when it comes to better reliability, we can like make use of pretty expensive services. But will that be the ideal solution for our customer? Like we have to think on our customer shoes as well. So we have to think about the cost optimization, and always we have to think about the security. So AWS has come up some best practices and encapsulate them into these 5 pillars, and created the well-architected framework. And also they have made a different set of lenses. By lenses, that means okay, you can use the generic AWS well-architected framework, and if you are developing a serverless application, you can make use of these guidelines to improve your serverless application. Similarly, they have lenses for IoT applications. Recently, they announced a lens for financial applications. So there are like a lot of startups coming up these days on fintech. So if you are someone who's building an application on financial domain, better to go and read the financial lens. And there are a few other lenses as well. So today I will take some of these principles coming out of this serverless lens to elaborate what are the things that we can do to get the best out of. So the first pillar that I'm going to discuss is the reliability. So in this reliability, we are talking about how better that we handle failures, how better we can handle the demand, the scale, and things like that, handling network interruptions, things like that. So in reliability, the a few things that they have given for server specifics. The first one is how do you handle inbound requests? So as you know, you can create an application. Maybe you can plug a REST API and expose your application to public, or like a set of pre-identified services. But what if these people try to abuse your API? What if they start DDoSing your service? So you will have to think about your inbound request. So if you don't think about these things, you might wake up to a very large bill. If someone try to DDoS your services. So there are multiple levels that you could handle inbound request. One of them, one of the popular places is the API gateway, and then another place that we can think about is the Lambda. So we'll discuss what are these things. So uh, whenever we design our application, the income request, we have to think about throttling. So one of the best part about throttling is whenever we identify any unknown access patterns, we can throttle those requests. And when you design these throttles, you have to think about the number of requests. And throttling can be enabled at, as I mentioned earlier, API gateway level, and there are some throttling in Lambda, which is called concurrency control. And also, one of in API gateways, one of the things you can use is API keys, which is not the highly secured way, but you can make use of API keys to do some metering and things like that. So this is what I mentioned on Lambda. Whenever you are having some Lambda function, you can decide, okay, how many concurrent function invocation that I'll be allowing. The thing is, imagine you have a Lambda function which will connect to a MySQL database. So imagine somehow someone is making large number of requests, and each Lambda function for some reason try to open up a connection to your database. So that means at some point your connection pool will be exhausted, and your entire application, there's chance that your application will go down. If you have only one single database, that's a pretty bad scenario to be in, because that will break everything up. So you can, for some selected database function, you can have concurrent limit. Say now in this case, we talk about the database layer. So to access database, we can have one lambda which have only one concurrent, like one time access. So that means you have a number of requests coming into a lambda, but you are allowing only one request to pass through the database. And similarly, if you identify that okay, someone is trying to do some bad thing, you can basically reduce this concurrent limit to 0 to prevent that some people trying to steal your data or do some bad work in your database. And the next thing I'm going to talk about is the building the resiliency of your application. So when it comes to the resiliency, now there are a lot of things that we can do. Earlier days, we most of our web applications are request response based application. So sometime when a request goes in, we have to wait for this request to be complete. So now in the application development panel, we can make use of asynchronous calls and events. So to do this, we can use queues, pop-ups, webhooks, things like that. So imagine you issue a request from your web client, which takes some time, not a very long time, but you can make use of webhooks to do like your application will send the request and your Lambda will do the processing, and using webhooks, you can notify back to the web client, okay, things are ready now, and then you can make it like the data, like retrieve the data, which will allow better user experience. And again, when it comes to reliability, the next thing is the failure management. How do you handle failures? What can we do when something goes wrong? So there are multiple options. The first one is the retrying mechanism. What we have to do is implement the better retrying mechanism. And then another thing is that if we are using something like queues, means we are at some level, we are making use of queues. So all our incoming requests will be going to maybe one queue or multiple queues, depending on that. If something goes wrong, maybe we can push the failure request to a DL queue. That means a dead letter queue, which we can like later use for debugging purpose. And with step functions in Lambda, that means we can have a state machine. There's something called Saga. Saga is not related to AWS, but it's a general practice where when we develop a event-driven application, just imagine one transaction involved multiple actions, like multiple steps. So if something goes wrong in a step, we can roll back like step by step. So using AWS step functions, we can easily achieve that. For example, now imagine uh, this is coming from like the serverless lens, this example. So this example, we have the booking hotel. Uh, booking hotel, booking flight, and booking rental. So imagine you try to book hotel. If something goes wrong, you can basically cancel. Let me use the pointer. When you try to book the hotel, if it succeeds, you can go and make reservation for the flight. Let's say that fails. There's no problem. So you can basically go back to cancel hotel and do the rollbacking of that service and end your function. Imagine like if you are making use of queues, you can use some of these steps to dump the event into the DL queue. So imagine, okay, your booking hotel function got succeed. Then you are in the state machine going to flight reservation. So similarly, if it succeeded, you can move to booking rental. But if it get failed, you can go to the cancel flight. So in this state, first you do the canceling of the flight, and then you move back to cancel hotel state, and you do the processing there, and ending your to the hot state. Similarly, in the success final state is you in the rental, Even in that case, if you succeed, okay, finally you can notify your front-end or the user that the operation successfully completed. But in the final case, if it fails, you can move into cancel a rental state, and then push that to cancel flight state, and cancel hotel state, and finally going to the end state. So that's how you can make use of sagas using step functions. Okay, so that's about it for the reliability pillar that specifically for service application. Next up, I'm going to discuss about the things that we can specifically use on servers for performance efficiency. Like in serverless applications, there are for the performance, we have different things. First, how we do selection and things like that. So if we think about the selection of services, let's say you have a lambda function. So these lambda functions are tied to a memory unit, which is directly correlate to the CPU, network, and storage IOs. So if you think about the to get the better cost optimization and decide to go ahead with the lowest memory and to have it like 128 megabytes, you have the option to pick 120 megabytes as the RAM. That means at the end of the day, you are getting lower CPU, lower network, and lower storage IOPS. That means okay, it seems like you are consuming low memory, but at the end of the day, to process this workload, you are going to get lower CPU. There's a very cool GitHub project I will share at the end of the session with all of you, which will take your Lambda function, and it will run in different configuration. It will run on like a very low level RAM, and it will try to run it on very high RAM usage, which is correlated to CPU and network and storage IOPS. And it will identify what's the best configuration that you can use. So whenever you develop a lambda function, you have to think about, okay, what's the best configuration that I have to select. And also, when it comes to the placement of this lambda, are you going to place it in a VPC? So when it comes to securing infrastructure, one of the a popular construct is the virtual private cloud to use VPCs. But if you use your lambdas, almost all your lambdas inside VPCs, that means there will be a performance in the when it comes to the execution. So in AWS, what they advise is place your lambdas on VPCs only if you need to do so. Otherwise, don't place your lambdas in VPCs. Next up is how do you pick your API? Uh, so depending on the application. So imagine we are building an application that we know for sure that we are serving to Sri Lankan customers. That means, okay, we know that it's going to come from Sri Lankan region. So we can make use of Mumbai infrastructure to serve our application because currently we don't have any region in Sri Lanka. So we'll have to make use of the closest region. But imagine that somehow you scale, your business expand to global, and you need to serve different locations in Sri Lanka, in Singapore, in Europe, and in US, things like that. Then you can make use of the edge locations which I mentioned earlier. So you can make use of CloudFront edge locations for API gateway to get the request. And similarly, another selection would be the DynamoDB. So when it comes to the your DynamoDB table, how we are going to partition your table. With this, you will in DynamoDB, there are some consideration that you have to think about how you're going to partition, and are you going to use on-demand DynamoDB table, or are you going to use provision? So always provisioning will have a bit of a cost, but then if you know that you can get better advantage by having provisioning infrastructure, that's going to give you like a better user experience. If so, you can always go for the provisioning infrastructure. The next thing is how you optimize. So when it comes to optimization, you always have to think about the trade-offs and the SLAs that you're going to give your customers. So in API gateways, when it comes to serving your responses, you can ask, do I need to always give the most updated data? So in cases like say that for some part of your application, you might not need the like a most recent update. In that case, what you can do is you can make use of API gateway caching. So there are two layers. So imagine you are using REST API on API gateway. You can make use of the API gateway caching, and if you have a GraphQL API, you can use that sync caching. And another thing that you can do on API Gateway is content encoding and GCPing your responses. So recently, even in one of our application, what we encountered was the response size is pretty large. Therefore, that our web client taking so much time to capture this response. So by compressing your response, it will have pretty like enhanced enhanced response time to your clients. So that will ultimately improve your user experience. And when it comes to the database, in DynamoDB, there's something called DynamoDB acceleration. That's called DAX. So in a recent community talk, Manoj discussed in depth about these DAXs in DynamoDB, who we can use. So with DAX, there's always going to be a cost inclusion. So because this is an in-memory cache, but it will give a very high like a response, like sorry, a very low response time when it comes to serving your data. And again, you can make use of the global GSIs and LSIs to indexing and get better query performance. And how do you optimize your lambda? So in lambdas, we can one of the things that we have to be aware of is the timeouts. So sometimes we blindly uh, enforce higher timeouts, but sometimes with imagine one of our lambdas try to fetch some resources externally, and we have implied that inside the lambda code we have implemented a retry mechanism. So imagine one of the requests get failed, it will take so much time for the retry happen. But to get the final timeout, it will take so much time, and ultimately it will incur a cost. If you think about a single invocation, that might not be the case, but when it comes to the scale, and if you have a high scale, that small sense will add up to large number of dollars. And another thing that we can do is always load test our lambda. And with load testing, you can earlier I mentioned you can tune your memory and CPU. You can use loads to identify what is the best configuration that we can use to optimize our lambda. And always as we mentioned, we have to keep our lambda minima. So we have reduced number of dependencies that we are using inside our lambda. And inside this lambda, there's something called global scope, which we can use. So as you know, when a lambda gets up, when the request fulfills, the lambda doesn't go it doesn't fully take off lambda instance. It stays up for some time. So if there's a concurrent consequent request comes in, it will reuse the same lambda instance that was created earlier to serve this request. So imagine if we can use this same container to have the database connections or thing, it will not have like it won't have to create connections multiple times. So that means we can like when it comes to network operation, it will have a very longer time. But if you can make use of these global scopes very well, you can cut down those network traffic and improve your performance in Lambda. And another thing with GraphQLs, what you can do is for like imagine that we have to get updates for one of our data updates. In a typical use case, what we can do is we can like use page refresh or continuously polling the database to see what has been updated. But if we develop our application in GraphQL manner, what we can use is GraphQL subscription to update the front end. So which will take down entire our polling mechanisms and improve the user experience very well. So that's about the performance optimization. Next up, I will discuss a bit about the cost optimization. So when it comes to the cost optimization, entire serverless services are pretty cost-effective solutions, but there are places that will, using some configuration, will incur some cost. But this is a design decision that you have to take inside your team. If you are going to use something like DAX, it will always have a cost impact. But if we are ultimately bringing down a lot of customers to their serving fulfillment, uh, even though short term, it will add a cost, but it will add much more value to your business. So that's one consideration. And as you all know, all the serverless resources that we are going to use is pay per value. And another thing is that we have to use is CPU and execution time. That's where I talked about Lambda. So if you use like a lower memory, it will take a longer time because for lower memory, you will get lower CPU and ultimately end up on longer processing time. So you can make use of a bit of a higher memory. So you can, I will share the GitHub repo. There they have done a pretty good comparison between different memory configuration, and they have proved that it doesn't matter for like up to certain workloads. It doesn't matter if you use like 500 mega 512 MB RAM or 1 GB or 2 GB RAM. There will be like very small pricing difference, like to the like 10 to the negative third or fourth level of difference between price, but you will have a very better performance when it comes to the execution. In some case, it will take about 100 millisecond, where we are using about 120 megabytes, but it will take about like 2 to 3 second execution time if you use about 2 GB or like 4 GB RAM. But again, at the end of the day, having pretty much similar cost. Uh, Another thing that we have to, what we can make use of is using the cost explorer to identify what are the places that we use spend money on. And we can think about this and always question, okay, do we really need this? And with the business decisions, you can cut down certain service usages. And another thing that we have to be careful about is the logging and logs retention periods. So imagine your application is been running for like 10, 15 years. Do you really need the logs that your application had on your first year? So you can think of these things, and maybe you can aggregate certain logs and come up to push it to certain VI dashboards and maybe archive it. So most of the time you store your logs on S3. You can change your lifecycle to have it on infrequent access, or better push it to something like Glacier. And another thing that you can do is remove unnecessary login. So imagine in your Lambda application, Lambda function, you can make use of logging in different really useful stages, or you can try to put logs in every line. But do you really need, sometimes when it comes to debugging, one of the popular thing that we do is put console logs, like in terms of Node.js application, what we do is push console logs throughout all the function to see, okay, at this state, what's our output. And sometimes if we don't do a proper code review, sometimes these functions end up in production level. So you have to try to remove this unnecessary logging. So that's something we can do when it comes to logging and storage. And uh, when it comes to serverless application, there are different ways to use the services to get some functionality done. So in this case, imagine we want to capture the click usage in our application. One of the practices that we can use is get the mobile client to send those requests into API gateway and use a Lambda service to process these click events, and then push to Kinesis, and ultimately push it to S3. So basically what we can use is use service proxy features, and we can remove the Lambda layer if we really don't need it, and basically cut down the cost that we are using going to spend on this Lambda. Or else we can remove the API gateway also using direct Kinesis Firehouse SDKs and push it to S3 using Firehouse. So that means we have removed API gateway as well as Lambda both. So, but these different patterns will have different things to consider. So, one of the security might be not high as using API gateway in using the SDK. So that might be something that you will have to think about. So all these decisions will have pros and cons. What you will have to do is decide what's best for you. And another thing is optimize your code. For example, earlier I mentioned about global scope. And then another thing that you can use is manage service features. So this example is coming from AWS documentations where it tries to, the two different option is, it has large object. So it try to get the entire object and filter out certain parts. So you can see the entire this operation has take 200 seconds. Or you can use something like Athena SQL or S3 Select, which you can S3 provides. You can query certain data from S3 itself and get the data. So that in AWS benchmarks that these two solutions have given the first way, like getting the entire object and doing the processing by yourself, have given 200 seconds, where it has gone down 50%, where it has used make use of AWS managed service features. So always when you design something and or when you implement something, question, is there a better way that AWS is using? So have they given us any functionality or service for us to make use of? So like sometimes there might be options that they have given which will allow you to cut down the execution time and ultimately cost drastically. The next pillar is operational excellence, like how you operation your business and altogether ultimately entire service operations. One of the main thing is in operation is application health. So is your API up? All your requests are getting served properly, or how many requests getting failed, things like that. So when it comes to these application health, one of the crucial areas is matrices and alerts. So in AWS, the things that we can use is CloudWatch and per service dashboards. So in CloudWatch, they have given us the ability to create multiple dashboards according to our needs. And what we can do is we can aggregate our business matrices and combine them with your service level outputs. For example, imagine your order conversion rate with your application performance, things like that. You can create dashboards to see where your status are. And then you can use some things like system matrices, HTTP, mem utilization, throttling, and integration latency, things like that, and operational matrices. Imagine like you can always think about your CI/CD pipelines. Are the builds being properly done? How many builds are failing for a given period of time? How many tickets are being addressed, and like the lead time generation, things like that. Always you can go ahead and push it to CloudWatch dashboards, and you can always analyze it. And another thing that you can make use of is alarms. So you can use alarms in many different levels to identify the service needs. So you may need alarms at your compute level, which is Lambda. So imagine something goes wrong when it comes to compute, like processing, or another place you need alarms is API gateway. Imagine suddenly you get usually you get 1,000 requests per second, but all of a sudden you start getting 100,000 requests, and you should be alerted when things like this happens. Another place you might need alarms is SQS. So when it comes to serverless application, since we are using different services, you might need to identify, okay, where are my bottlenecks happening, or like what are the services hindering my entire application performance. So you can use a service called AWS X-Ray, which helps you to identify service bottlenecks, as well as you can see, okay, a particular request comes in, and how this request being passed on to different services, and how long it was there in these services, things like that. So as you can see, these service graphs, you can easily identify what are the places that you need to address. So that's something pretty cool when it comes to operational excellency. And when it comes to application lifecycle management, uh, there are different states that we have to be that we can get better use of, like prototype, testing, and deploying. Imagine you want to create a new feature. You can create an entire, imagine you had to your entire infrastructure as code. You can easily create a separate isolated environment, and you can deploy your entire application there, and maybe do some user testing, and make see how users interact with this. And unlike traditional infrastructure, this will give you a better chance at dealing with customers to get much better feedback. At the end, you can use these feedback results to improve your application. Final thing I'm going to talk about is the security aspect. So in security, there are different things. We have to talk about identity and how the access management happens. And then we have to think about how do we detect something goes wrong. And we have to think about how do we protect our infrastructure, how do we protect our data, and how do we uh, respond to incident which happens. So first we'll look at the access control. So when it comes to access control, there are four different ways that we can use. One is the IAM authorization. Next one is cognitive user pools. And then we can use custom authorizers on gateway land authorizers, and we can make use of resource policies. So always you have AWS credentials. One way is to pass down these credentials as is using SDKs to gateway and onto different Lambda function. But these have very different security implications. You can think about, okay, what are the areas that these credentials are available? So what if these credentials are being leaked to someone else? What can he do? Things like that. Or else you can have Cognito do the authentication. So basically, you can plug in the Cognito to API gateway level to do the authentication and authorization. And similarly, if you are not fan of Cognito, or you have a different way of securing your application, say you have different auth provider, you can make use of that. Basically, you can write the authorization logic in a Lambda function and hook it to the API gateway. So when some request comes in, it will all the request will go to the Lambda authorizer. You can pretty much you have freedom to implement this, or you can use your auth provider or the way you doing your authorization. And depending on the result, you can always apply a policy and pass it down to land level. And the final method is using resource policies to pass down and access features. So different features might have different security implications. So you have to think about, okay, what are the secret needs which my application has, and what's the best way that I can use. So depending on that, you can decide on how you can secure serverless application. And next up, let's talk about the detective controls. Always you can use your logs to detect if someone try to do something wrong in your application. And another thing you can always do is you can check your code and dependencies using open source tools like OSAP. So this is a very good practice that you can use AWS SDKs as well as your dependencies get checked with OSAP, because OSAP always try to keep update their secret checks up to date. So try to check your dependencies and application with OSAP tools, because that will give you a better visibility on where you are in terms of security. And when it comes to infrastructure protection, there are different things that you can use. One is using VPC, and another thing is using network boundaries. And another one last thing you can do is using dynamic authentication for service to service communication. uh, and finally, if we talk about the data protection, one of the things we have to be really careful about is the log management. Just imagine you are trying to log everything which comes to your API gateway into log. Imagine you are developing an application which has to be in compliance with GDPR. So imagine one of the requests comes in which has user information, and you have to be really careful how this sensitive information will be logged. So yeah, you can always encrypt your sensitive data and pass down to API gateway, because then what it gets logged is the sensitive data. Or you can always skip the logging this sensitive data from logging. Uh, and always check your compliancy. What are your application needs, and what are things that you have to be in compliant when it comes to logging. And so that's pretty much it related to serverless specifics. Then if you want to read more on, you can always use the well architected framework. And also, one of the cool things that AWS has provided is the well architected tool. So let me go to the application. So this well-architected tool is something you can use to measure your architecture. So you can check how you are doing in terms of the design. So let's try to do some test deployment. One thing I will have test. So we'll try to create a simple thing. I will pick a region, and you can give your account IDs. These things are optional. And then you can check if it's a production or pre-prod environment. So in here, you have the option to see what's the framework that you are going to use. Is it going to be the well-architected framework or serverless lens? So for the demo, I will use serverless lens. And here, you can start reviewing what are the things that you can do. So basically, it will ask a set of questions from you, and you have to answer what are the things that you do in your application. So, for example, let's see in Serverless Lens, we'll try to review, and it will ask how do you evaluate your serverless application health. So there are different options. So you can either pick a question does not apply to my workload, or you can say in this case we'll see we are using uh, understand, analyze, and alerts. And we'll go to the next question. Next question is how do you approach application lifecycle management? So all these things are discussed in serverless lens. Basically, they have put it into questions, and you can pick certain generic answers. Here, let's say we use a rollout deploy mechanism. Say, and we can click next. Okay, so let's go to see our serverless lens performance. So we have one high risk and we have one medium risk. So you can generate a report to your architecture. And if we open up this, so they will provide a well-architected tool test serverless lens report. And it will have a lot of information on what are the high risk. There's something with high risk is operational excellence. So if we go inside that, you can see they have included improvement plan. So this is something really cool. So imagine you are someone new who comes to service application and you design application. What you can make use of this, you can try out this well-architected tool to see where are the places that you can improve your application. So basically for everything, they will give you a risk and the improvement plan. What are the things that you can do to improve your entire application architecture? So that's pretty much it, what I wanted to cover. I hope you gathered some knowledge around getting the best out of your serverless application. I think with that, I can conclude the session. Manoj, over to you.
Thank you, Rumesh. I think that is a very useful and practical presentation, Rumesh. I think it's going to definitely help a lot of people who are using serverless applications. Especially, I really like the audit tool that you just showed. It's going to really come handy. So we can open a quick Q&A session. So if you guys have any questions, we have Rumesh. Now is the time.
Yeah, Rumesh. So I would like to know, is there any way to do dynamic, to configure dynamically provision capacity? For an example, let's say like there are set of APIs, and that set of APIs are receiving traffic now. So we can come. So that tells that there's another set of APIs. They are supposed to get higher number of hits in maybe like in coming seconds or maybe in coming minutes. So is there any way that we can dynamically let the AWS know, okay, I need the provision capacity for this set of lambdas?
There are one way is they have a concurrency provisioning. That's something actually I haven't used a lot. So that's provisioning, concurrency part is something I know. Manoj, do you have any input on that?
So one of the things I think we may can look at is the at API gateway we can have some throttling usage plans. So there, like we can define different usage plans or the savings plan. I can't remember exact what that particular word. So they are like we can define different throttling. Let's say if your customers are from different tiers. So if they are professional tiers, so so they must have some infinite access to your APIs. So for them, like you can have a throttling defined for high number of requests. So if there are free tier also, we can have a throttling defined, maybe a lower level. So depending upon a certain attribute like the customer's tier, we can have different throttling set up at API gateway. Thereby, it will invoke the lambdas. And yeah, so that is one of the ways, because anyways, a particular AWS account has 1,000 Lambda concurrence requests, which you can, of course, increase with a support ticket. So I think that is one of the ways that I...
Yeah, Manoj, the problem is like it will throttle, right? But what we need is a provision capacity for set of lambdas. And the thing is, this provision capacity has to be dynamic as well, based on the whatever our current capacity, current number of requests that we are, concurrent requests that we are receiving. We need to enable that. So one thing that might be possible is based on the CloudWatch logs, using something like that. But so this is some problem that I am actually going through. So that's why I put forward.
Have you checked, like let's say you can define different lambda function? I mean, normally, let's say if your users, I assume, like again, I'm assuming, like if they're in a paid tier also, for them, like you can define a separate lambda with that
different concurrency levels,
with a different concurrency level. And for the other tiers, you can define a separate lambda with a different like lower concurrence rate. So that, I mean, you will have like two separate lambda where you will like trigger depending upon maybe their tier.
So that is something that we are currently doing. But the problem is, as soon as we define the provisioning capacity, we have to pay. So
that's right.
Yeah. So, but this is kind of like first stage. When the first stage hits hard, so we anticipate that the second stage also has to be get ready for the subsequent request. So then we can dynamically provision that rest of the path. So in that case, we can save more. Otherwise, go ahead. Go ahead, Rumesh.
So what I wanted to say is, like having a predefined set of like different lambdas would be one of the ideal ways. But to get the, like as you mentioned, get the like the true full dynamic nature, in my side, I don't think I have an answer.
So are you currently trying out a CloudWatch and then triggering like changing the
alarms.
provision cap alarms, and through that changing the capacity?
That is the only hope, but still that that is the problem. Thank you very much.
Yeah, thanks, Priya.
Hi Rumesh, I am Harilpi. This Lambda serverless thing is very new to me. I am familiar with the Spring Boot, Dockers and load balancing, and this Spring Boot persisting feature to persist the data to the database. So if we adapting from that to, if we move to the Lambda, can we use frameworks, or should we write in the plain Java? Then how we able to connect to the database and everything? Can you explain?
Right. So Rilpi, right? Sorry. Yeah. One thing you could do is, instead of trying to write everything from the scratch, what you can do is you can strangle parts of your application, let's say one endpoint at a time, and then convert it. So yes, you can use certain frameworks inside the Lambda functions, but it's always try to make use of services that AWS provide. So instead of having like an entire Spring framework running inside your service, what you can do is think about the functionality. Okay, I want, let's say, to serve some customer related information. You can think about that endpoint and certain functionality. You can get the functionality into a Lambda function, and then plug it into the API gateway as an endpoint. So you can have a proxy saying, okay, some parts will go to your existing Spring Boot application, and the rest of the new application that you're building will have a certain path. So that request will come to the Lambda function itself. Yes, you can use framework inside the Lambda, but it's not the best way to do it, because that will have a very heavy load inside the Lambda function. So it's advisable to have it bare minimum, because instead of using the Spring Boot framework inside the Lambda itself, you can make use of other services to get the functionality done. So I'd say isolate parts of your API and convert the function, those logic into the Lambda function and hook it up to the API. And then part by part, you can move on to serverless.
Thank you very much.
Yeah, sure.
Okay, guys, are there any more questions? So I think right now we can wind up our May meetup. So it has been really a good meetup with both these insightful speakers. Thank you very much, Suman and Rumesh, for your great presentations. I hope like everybody learned something out of them. And also, guys, thanks for joining us online again. Thanks everybody, and have a good evening.